proper choice of constant, with proper choice of, this is the particular integral with proper choice of constant c3, c4, c5, c6. So in order to find this is the particular solution of equation 1, means equation 1 is satisfied by yp. First find dyp. What is dyp? c4 plus derivative cos 2x is minus sin 2x, so minus 2 c5 sin 2x plus 2 c6 cos 2x, and d square yp is what? Derivative of c4 is 0, minus 4 c5 cos 2x plus 4, not plus, minus 4 c6 sin 2x. Derivative of cos 2x is minus sin 2x into 2. As yp is particular solution of equation 1, we have, what we have? Equation 1 is satisfied by yp. That is, we have d square plus d minus 2yp is equal to 2x minus 40 cos 2x. Yeah, this, that is, we have d square yp plus dyp minus 2yp is equal to 2x minus 40 cos 2x. That is, we have d square yp minus 4 c5 cos 2x minus 4 c6 sin 2x plus dyp is what? c4 minus 2 c5 sin 2x plus 2 c6 cos 2x plus, not plus, minus 2yp c3 plus c4x plus c5 cos 2x plus c6 sin 2x is equal to 2x minus 40 cos 2x. So collect the coefficients. Next step. So we have c4 minus 2 c3. This is constant coefficient plus the coefficient of x minus 2 c4x, then coefficient of cos 2x minus 4 c5, this term, then minus plus 2 c6 and this minus 2 c5 cos 2x, the coefficient of cos 2x, then coefficient of sin 2x minus 4 c6 minus 2 c5, this term, then this term minus 2 c6 sin 2x is equal to 2x minus 40 cos 2x. And this implies, comparing the LHS and RHS, c4 minus 2 c3 is equal to 0. The constant coefficient in LHS is this, and in RHS is 0. Then coefficient of x is what? Minus 2 c4, and in RHS it is 2. The next equation, minus c4 c5 plus 2 c6 minus 2 c5 is equal to minus 40, coefficient of cos 2x. And the coefficient of sin 2x is what? In LHS this is the coefficient, and in RHS the coefficient is 0. So after solving these equations, 4 equations, we have the values of c1, c2, c3, values of c3, c4, c5, c6, and that values are the value of c4 is minus 1 from this equation. The value of c3 from this equation is, value of c3 is minus half. c4 is this minus 1, and then the value of c5 is minus 12, and the value of c4 is 10, and therefore the particular integral is y is equal to yp is equal to c3, that is minus half minus c4x, that is minus x. This is the particular integral, c3 minus plus c4x plus c5 cos 2x. Substitute this c3, c4, c5, c6. We have this minus 12 cos 2x c5. Then c6 is what? c6 is 10. c6 is 10 plus 10 sin 2x, and therefore the general solution is what? Y is equal to c1 e raised to minus 2x plus c2 e raised to x, particular complementary function, plus minus 1 half minus x minus 12 cos 2x plus 10 sin 2x is what? This is what is the general solution of the given differential equation. The general solution of given differential. Then next problem, solve d square minus 1y is equal to e raised to minus x 2 sin x plus 4 cos x. So in short, what are auxiliary equation? The corresponding homogeneous differential equation is what? D square minus 1y is equal to associated homogeneous differential equation. And the auxiliary equation is this. So m square is 1. Therefore m is plus minus 1. And therefore the complementary function is yc is equal to c1 e raised to x plus c2 e raised to minus x. Then this term e raised to minus x 2 sin x plus 4 cos x corresponds to roots what are minus 1 plus minus I, minus 1 plus minus I, and therefore these are the m dash, and therefore this e raised to minus x 2 sin x plus 4 cos x is the solution of homogeneous differential equation d minus 1 plus I into t minus 1 minus I minus 1 minus I, y is equal to 0. D minus first root, d minus second root. What are the roots? Minus 1 plus I, and another root is minus 1 minus I. So first d minus this, y is equal to 0. Solve this. So this is d minus plus 1 minus I, d minus plus 1 plus I, y is equal to 0. So right here bracket. So the multiplication is what? D plus 1 bracket square minus I square, y is equal to 0. That is what? D square plus 2d plus 1, I square is minus 1, so minus plus 1, y is equal to 0. That is d square plus 2d plus 2y is equal to 0. And so by combining the values of, write the remaining part, that is by considering together the values of m and m dash, the homogeneous differential equation is corresponding homogeneous differential equation is what? Is d square minus 1 d square plus 2d plus 2y is equal to 0. This is equation number 5th. And its solution is what? y is equal to c1 e raised to x plus c2 e raised to minus x plus, that is d square plus 1 is equal to 0. The roots of d square plus 1 is equal to 0, or what, plus minus 1. That term is this c1 e raised to x plus c2 e raised to minus x plus the roots corresponds to this, what, these are 1 plus minus minus 1 plus minus I, and the terms corresponds to these roots minus 1 plus minus I are what, e raised to minus x, next constant c3 cos x plus c4 sin x. So by equation 3 from 6 we have yp is equal to, that is delete this part, complementary function, yp is what, e raised to minus x c3 cos x plus c4 sin x with, and this is what, this is particular integral with, this is particular integral by c by 3 its solution. This is the solution of equation number 5, and by equation 3, that is equation 3 is this, y is equal to, that is by deleting this part we have the particular integral with proper choice of constants, that is find these constants c3 and c4. Then find dyp. dyp is what, by using u into v rule, e raised to minus x minus c3 sin x plus c4 cos x plus derivative of e raised to minus x is minus e raised to minus x c3 cos x plus c4 sin x. This is what, dyp, d square yp. Simplify this. So this is e raised to minus x is constant, minus c3 sin x plus c4 cos x minus c3 cos x minus c4 sin x. That is we have e raised to minus x minus c3 minus c4 sin x plus c4 minus c3 cos x. Then d square yp, e raised to minus x, derivative of this quantity, minus c3 minus c4 is constant quantity, sin x derivative is cos x, plus c4 minus c3 constant quantity, derivative cos x is minus sin x, so right here is minus sin, plus, not plus, minus derivative of e raised to minus x is e raised to minus x into minus 1, bracket as it is right here, bracket what, minus c3 minus c4 sin x plus c4 minus c3 cos x, and therefore we have d square yp is e raised to minus x minus c3 minus c4 minus c3 minus c4 cos x, coefficient of cos x, and here the coefficient of cos x is plus c4 minus c3 minus c4, this negative effect of negative, here is also the effect of negative this term, so this is minus c3 and c4. Okay, so we have in bracket minus C3 minus C4, the coefficient minus C4 plus C3 cos x, and the term of sin x minus C4 plus C3, this term, and this term plus C3 plus C4 sin x. And so we have e raised to minus x in bracket minus 2c4 cos x plus this term 2c3 sin x. Then equation 1 becomes, as yp is what? Is solution of equation 1. And so we have equation 1 is this d square minus 1 yp is equal to e raised to minus x 2 sin x plus 4 cos x. Equation 1 is satisfied by yp. That is d square yp minus yp is equal to e raised to 2 e raised to minus x sin x plus 4 e raised to minus x cos x. And d square yp is this. So remains this as it is, 2 e raised to minus x 2 sin x plus 4 cos x. And then d square yp is what? E raised to minus x in bracket minus 2c4 cos x plus 2c3 sin x minus yp is this. Yp is what? E raised to minus x c3 cos x plus c4 sin x is equal to e raised to minus x 2 sin x plus 4 cos x. So comparing LHS and RHS, we have the values of c3 and c4 and substitute that values of c3 and c4 in this yp. What is yp? Yp is e raised to minus x c3 cos x c4. So this implies minus 2c4 coefficient of cos x. Here is what? Minus 2c3. This is LHS minus 2c3 minus c3 only is equal to minus 2c4 minus c3 is equal to 4, and another constant is what? 2c3 coefficient of sin x, and this is minus c4 is equal to coefficient of sin x is 2. And so solve these two equations combinedly, find the values of c3 and c4 and substitute these values in equation number 7. We get the particular integral, and then the general solution is what? Y is equal to yc plus yp.